Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 36. We are continuing our investigation of trigonometry, and now we want to derive the power reduction formulas for sine, cosine, and tangent. So we're going to begin with, how about cosine? So in the previous videos, we learned about the double angle identities for sine, cosine, and tangent, and in particular, we learned that cosine actually had three variations. We learned that cosine of 2 alpha, for example, was equal to cosine squared alpha minus sine squared alpha. This is the same thing as 2 cosine squared alpha minus 1 and 1 minus 2 sine squared alpha. So where we are going to begin for deriving the identity for cosine is actually starting with this identity here. Alright. So if cosine of 2 alpha is equal to 2 cosine squared alpha minus 1, our objective is solving for this quantity here. I just boxed in green. We want to isolate the cosine squared because our goal is we want to express that cosine squared, so cosine to this power, in terms of cosines without exponents, and to do that we're going to use our double angle identity. So first thing we need to do, of course, is add 1. So we get cosine of 2 alpha is equal to 2 cosine squared alpha. Then we divide out the 2. And, oh, I forgot my 1. That's funny. So, and then we are done because that cosine squared alpha is now isolated. And you have a way of expressing it in terms of a cosine without a power. So this is our first identity. We'll box it in blue. And the process is actually very similar for sine. So if we had noticed, cosine of 2 alpha was also equal to 1 minus 2 sine squared alpha. So all we have to do is just isolate the sine squared here, and then we get our nice identity. So again, we will subtract the 1, and then we will also divide out 2, but in this case it's a negative 2. Well, in the previous example we had to add a 1, so slightly different, but whatever. See, we added 1, we subtract 1 here. So we get cosine of 2 alpha minus 1 is equal to negative 2 sine squared alpha. We divide out the negative 2. And this negative 1 and this negative 2 is going to become, I'm going to cancel out the negative. Okay. So just to be clear, off to the side, we have a negative 1 plus cosine of 2 alpha. So I am going to apply, we could think of it like this here if you want. So these negatives will die out, and its cosine is going to become negative because of that negative there. So this is kind of some of the middle work in case it got lost in the algebra. So that's what I meant by this circle in the green here. So what's going to happen then is you get a 1 minus cosine 2 alpha, this entire quantity, over 2. As if we work this out a little bit more, right, we get here 1/2 minus cosine of 2 alpha over 2, and then that brings you to our next step. And this, of course, is equal to sine squared alpha, and that is what we wanted to show. That sine squared alpha can be reduced in terms of another trig function. So now that we know what sine and cosine, or sine squared and cosine squared are, we can actually do tangent now. So tangent squared of alpha is going to equal sine squared alpha over cosine squared alpha, just using this identity. Tangent x is equal to sine x over cosine x. And since we already know what sine squared alpha and cosine squared alpha are, we're going to directly substitute those in. 1 minus cosine 2 alpha divided by 2 over 1 plus cosine 2 alpha over 2. And we can note that the 2's will kill each other off, which is exciting. So that's going to leave us a 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. And there we go. That's our third identity. Alright. We'll box that as well. So to summarize then, let's see here. Right. So we showed that cosine squared alpha is equal to 1 plus cosine of 2 alpha, that entire quantity divided by 2. We have a very similar expression here for sine. Whoops! Don't know what happened there. Oh well. No, there we go. We have a very similar expression here with the cosine. So we have negative, and now we have our tangent squared, which is kind of the marriage of the two. Alright. So with that, we're going to conclude this video. Thank you for watching. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. Thank you for joining our math party, and we will see you next time.